All right, thank you everybody for coming. Last session of Ignite, very exciting. We are here to talk about how to deploy, how to scale and deploy enterprise search. So this is very architecture focused. We are working through our clicker challenges. So I mentioned a bunch of people that were in here early. We are going to be talking about in the context of SharePoint 2013. Most of the architecture between SharePoint 2013 and 2016 will be similar, or really the same, essentially. That's what we've been told. But we'll try to throw in some of the nuggets that we know about SharePoint 2016 search that will add a little bit of color and let you know that we are actually making improvements on that product. We're going to talk about hybrid search a little bit. So we're not going to go into details of how you configure it necessarily, but we are going to talk about how some of the hybrid components will impact your on-prem architecture. And then we have a few demos to sprinkle in throughout the conversation.
Who are you?
Yeah, thanks, Dan. Yeah, my name is Paul Summers. I am a technical architect at the Microsoft Technology Center in Boston. So I focus on productivity and collaboration workloads in general in support of our sales teams. But I joined Microsoft along with Dan through the Fast Search acquisition in 2008. So both of us have been doing search for quite a long time. I still spend a lot of time diving into the search topics, supporting customers who are trying to do search deployments.
Dan Benson. I'm a senior consultant for Microsoft Consulting Services. I work out of the East region, and as Paul mentioned, we both came over with the Fast acquisition. So we've actually did our first presentation together at Fast Forward 2009. It's been a while. So I still actually focus mostly on enterprise search. And go ahead.
Boom. All right, so just to give you a clear idea about what we're going to cover today. So the first thing we're going to talk about is the core architecture of SharePoint Search. So all of these components, what they do, what features they serve up, and we're going to talk about what kind of resources they consume and how that's going to impact your ability to scale them. We're going to talk about how we can scale out the architecture, how we can scale up the architecture as your requirements grow from your business. Then I'm going to add the hybrid components in. We're going to talk about the federated query hybrid approach. We're also going to talk about the Cloud SSA for those of you who haven't heard about the Cloud Search Service Appliance. We're talking a little bit about disaster recovery, the backup and restore procedures, and we're going to cap it off with monitoring, some monitoring topics, a little high level on monitoring. So I hope that's what you came here to see. We're going to ask you for an evaluation, so we hope we're targeting your expectations already.
So I'm going to start by talking about the core architecture. And as Paul mentioned, we actually have 3 different demos coming up in this. But we're going to get through some slides real quick just about the concepts, starting with the logical architecture. There we go. So real quick show of hands, how many people have seen this before? All right, I'd say that's about 40-50% of the room. So the good news is some of you are going to be learning about these components for the first time. Others of you, this will be a little bit of a refresher course. As Paul mentioned, I think before we started, this isn't going to change much in 2016. So we're not just talking about what happened back then. All right, so the components are going to be relatively the same. And at the end of the day, there haven't been a lot of changes in the last couple of years, right? You have content out there. You got to have some way to get it in a search engine. That's the feeding chain. You've got your search engine. And then on the right side, you need some way to get that content out of the search engine. The new component here, this little guy on the bottom, is called the Analytics Service, and that's actually new for SharePoint 2013. So we'll dive into what that's about. So starting with the feeding chain, excuse me. We start on the far left side with the crawl component. This is how we get our data into the index. So we've got data out there. We need to get a hold of it somehow. The crawler is responsible for acquiring content for the index. The purplish things you see there on the left side are the out-of-the-box connectors. They include SharePoint sites, user profiles, HTTP file shares, Exchange, Lotus Notes, Documentum. ... custom BCS on the bottom. That's a way that you can get your custom repository that isn't included in these connectors into your search index. So if you do a search on Bing for super simple BCS connector, it's a good place. A former colleague of ours wrote that, and it's basically a frame of reference for a scalable BCS connector that you can develop your solutions off of. One of the important things here, the crawl mode. So you're probably familiar, if you've been involved in SharePoint 2007, 2010, et cetera, in full and incremental crawl. What's new in SharePoint 2013 is the continuous crawl. So that gives us the ability to have our crawler sort of always running and looking for updates, and gives us maximum freshness, at least the maximum we can get from a pull. Right? There's still no way to technically push data into the index, which would be sort of real time, but this gives us as close as we can get to near real time. It's important to note that this only works on SharePoint data sources, SharePoint 2013, I should say. So from those data sources that are out of the box, you're talking about SharePoint and user profile crawling. So now we've collected the data, and we want to move on to the next component.
I also want to add to what Dan said, with the crawl database, that's really just a state tracking database, so we're not replicating the content in any way into that crawl database. And that has implications in terms of how you design your database structure, your backup and recovery procedures, those sorts of things. So a lot of people ask, are you persisting the crawl data into that crawl database? And the answer is no, it's purely for state tracking.
Worth mentioning, thank you for mentioning that though, the local disk cache bullet. The crawler does, and you need to watch out for this, wherever you have the crawler running on those nodes, it does write documents temporarily to a local disk cache. So if you have antivirus or something running on that machine and looking at that particular directory, that's something you could really look at for performance consideration. Because the antivirus is going to have to look at each document, it might actually throw some of them out. So just be aware of that. Next, we move on. We've crawled the data. We're moving on to the content processing component. This is one of my favorite components because it actually does a lot of work and gives us the ability to do some cool things. It's a stateless node responsible for analyzing the content that's coming in from the crawler. It goes through a flow, a processing flow. Some of you might be more familiar with the term pipeline, but there's basically stages in this that do different things, such as dictionary mapping, entity extraction. The schema mapping is one of the most important things, so that takes the crawled properties and maps them to managed properties, which is the index schema. It stores links and anchors in the link database for later analysis by the analyzing processing component. It is extensible through web service callouts. Configuration is stored in the admin database. So a couple improvements from SharePoint 2010 to SharePoint 13 mostly revolve around out-of-the-box title and author extraction. So the content processing component actually looks in the document for a relevant title. This is in lieu of just taking the metadata at face value, because you might have, I've seen a lot of customers that have templates stored, right? And people never actually go and touch the metadata, so you just have solution architecture template. And if that was the title for every document that came up in the search results, it wouldn't be a very compelling user experience. So it looks at that for title. It does the same thing for author. You might have somebody who imported a lot of data, right? And now they used a system account or something. And you see in the Refiner's author system, 1 million documents, nobody else, the rest of them. So it looks in there and does deduplication on the authors to try to find the best match there. The blue box on the top, the Content Enrichment Web Service. This provides a great opportunity for you to do something custom. Unfortunately, it is not available or planning to be available in SharePoint Online, but if you're using 2013 on-prem, you've got this web service callout that can allow you to hook into anything you want or enrich the data in any way you want. One example, I'm working with a customer right now, and they want to merge, they have a competencies database, so users' competencies are stored somewhere else other than in SharePoint. And right now, when you search for somebody, you only have the information that they typed in. But as the user profiles are crawled, we can actually reach out to that database, enrich the user profile with this person's competencies, and then when you're searching for people in SharePoint, you're able to get a lot more data in terms of expertise. If you're searching for project management, software, .NET expertise, et cetera, et cetera. So next, we've gone through the content processing component. We have our managed properties all squared away. We've enriched our data. We actually move the content processing component, sends that data to the indexer. The indexing core is responsible for writing the actual binary structures to disk. So the sort, the refinement, and the inverted index itself. So one of the things that's interesting about the index core as it is now in SharePoint 2013 versus previous releases, it takes about 1/7 of the IOPS that it used to require in previous releases. So this gives us the ability, in most of the reference architectures we're going to show, to really excel on virtual machines and in SAN environments. When we were architecting these solutions over the past previous 7 years or so, we were always talking about physical hardware, dedicated local attached storage, and we had a really hard time. It's very expensive to get the kind of bandwidth we needed in terms of IOPS to share a SAN with other applications. Okay, so diving into, and then it worked a couple times. Diving into what's actually in the index. This is where Paul was talking about how many of you heard of partitions and replicas. We used to call these rows and columns, but they're now called partitions and replicas, where a partition is a logical unit of your data, and a replica is a copy of that. So you can have up to n partitions. You have to have one primary replica, and you can have one to many secondary replicas. So the partitions are a logical, like I said, a logical partition of the entire index. So you would have one for 10 million documents, for example, and you would scale out. This thing's driving me nuts. I'm just going to move closer. You would scale out using the partition scheme I was just talking about. Now, if you look at the replicas in orange there, that's going to be your primary indexer, which is determined in the order that it comes up. So it's not, you don't set your topology anymore for one particular machine to be the primary. It's basically whichever one comes up first becomes the primary, and it uses journal shipping to the other indexers. They write their own structures to disk. As they catch up, the search results are then merged from the different replicas. So what happens if one of those replicas goes down? In this case, I took the primary down. Well, the secondary replica is actually going to pick up as the primary, and you're going to be business as usual for a while. Business as usual with a little bit of diminished query capacity. Okay, so we said we scale replicas out to be able to add both redundancy and query capacity. So if you lose one, you're going to be running at a diminished capacity, but you're still in business. So that next replica takes over. When whatever caused the first one to go down comes back up, it's now a secondary and getting journal shipping from the new primary indexer. And this goes for not just node failures, but when you're applying patches, the same thing. So whoever comes up first is basically in charge. Do you have something there? So we've got the information written to disk, we've got our search index, we've massaged all the data and got it in there. How do we get it out? That's the right side here, the query chain. So starting with the web front end, the user issues a query or a program, for example. This is where the query APIs are stored. The REST OData API, CSOM, server-side object model. This is also where the Search Center itself is hosted. That's where you get all your display templates as well as out-of-the-box web parts, the refinement, search box, core search results, and also the content by search web part. So next, we issue the query from the web front end, whether it's through an API or through the Search Center, even a content by search web part, and it goes to the query processing component. That's a stateless node. Much like the CPC, it uses processing flows, so it sends data through a pipeline that's analyzing the query, determining the language, word breaking and stemming, doing any dictionary mapping such as synonyms, for example. Items go through the result sources, any relevant query rules are fired. It also does the query federation, so we're going to talk about federation a lot today, but this is the component that's actually shipping that query off to either another SharePoint source or something that's OpenSearch compliant, so it could be an external source, and the configuration is stored in the admin database. So that's basically getting the data in, querying out. Now what's going on the side here is we have an analytics service that is running and processing streams of events. So it's using MapReduce, so as you scale these out, portions of the work are actually shipped to different locations. It learns by usage. As events come in, it's constantly working to update the index and enrich it, improve the relevancy, etc. So the search analytics part, we're talking about anchor text processing, search clicks, social tags, social distance. It's also responsible for the search reports and determining what the most important pages are, so deep links. Usage analytics, we're talking about counts, so usage counts, recommendations, and activity ranking.
One thing about this component, the way it gets those updates into the index, so you can see it's pushing those, those aggregated statistics up back through the content processing component, and we can actually update the record or the document in the index using what we call update groups. We also use that for security updates so that we get those updates much faster and don't have to reindex the full document when we have those sorts of updates.
Good point. And another thing that isn't exactly highlighted here, we talked about the content processing component pushing links into the link database. Well, this component is now looking at those links for link cardinality to determine relevance. So who's pointing at who the most, that type of relevance tuning. Just some examples of what the analytics service provides as you're looking at it from the UI. So the sort by popularity there in the middle, the view counts just below that in the middle on the hover panel. It provides recommendations. So people who have clicked on this document have also clicked on that document. Relevancy based on usage, search reports such as number of queries, zero-hit queries, top queries. And then in the type ahead query suggestion box, you also see, are you looking for these again? So it knows a little bit about you and your history, and will try to suggest the best query for you. Now, I would be remiss if I didn't mention this component. It's not super sexy, but it's like the middle manager of the whole system. It's responsible for provisioning the components. It stores the search configuration data, which was mentioned in almost every slide, that the search configuration is stored in the admin database. It stores the managed property mappings and things like that. But what's most important, why I wanted to put this slide up, is that the search admin component is now fault tolerant. So you can have a secondary admin component running, whereas you were never able to in the past, making all of these components now a fully redundant system. Fault tolerant. They go nuts. They go nuts.
There you go, Dan.
Okay, so before we jump into deployment and scaling, does anybody have any, like a quick question or two, or does anybody want a t-shirt?
I have swag if you have a good question. I have a large. Where's
on
the large?
any of that stuff we went through.
Saw that hand first.
All right.
Any questions down here? Do you want to come to the mic? Yeah. That way we'll get it on the recording. I don't think the mic's on.
We'll repeat the question.
We'll just repeat the question, sorry. Go ahead.
Imagine you have 6 partitions, 6 partitions with each one replica. The question is, SQL I/O tests. Must I run those tests in parallel on every node? Means on the master and on the replica?
So the question is if essentially, and let me make sure I've got it right, if I'm trying to test for IOPS capacity on my farm, should I run all those IOPS tests concurrently across all nodes? And I think to get an optimal view, Dan, I'll start and you can weigh in. To get an optimal view of your I/O profile, that's the way to go, particularly if you're using any type of shared storage, right? You know, if I'm hitting a SAN on the back end, I certainly want to make sure that I understand that concurrent access. There's also, you know, there is a network element to it potentially, and the way those things are communicating with each other. So I think that gives you the best view. But you could also, I mean, I think you'll get some insight on a node-by-node basis if you did it one by one.
Yeah, I mean, just to add to that real briefly, if you're just testing IOPS, you can probably run them independently. It depends on what else is going on in the system. But if you're like looking at query performance, you definitely want to test the replicas at the same time, right? Because remember, the partitions, the data is spread out. The queries are then sent to the replicas and load balance there. So you might have some different numbers based on as you zoom out of just like pure IOPS. Another quick one.
Hi.
Hopefully it's quick.
In December update, there's supposed to be a change where it's crawling supposed to be 2 times faster or whatever. But do we know which exact components are changing?
I think the question was with the December update, there was supposed to be
Not there is supposed to be update, which is
this coming December.
Yeah.
I'm not aware.
Not necessarily December. They say end of year, but.
We do. I know in this calendar year we're shipping a bunch of updates for SharePoint 2013, including search. That's where you're actually going to be able to get the hybrid, the cloud search appliance. I don't know about the improvements to the crawler. I see Brian Pendergrass here. Do you know Brian? I haven't heard anything about that. Okay. That's not to say it won't come. I know, for instance, with 2016 we're going to have improvements the way when you expand your topology, you won't have query downtime, stuff like that. Yeah. But I'm not clear on all the updates.
But it was said that even Bill Baer said it will be shipping the search part will be shipping at the end of year sometime.
Yes. Yes.
Do you know which part or everything is changing?
So we'll be shipping an update for SharePoint 2013, and I think it'll be larger than just search, but there will be some search improvements as part of that update. I'm not clear on comprehensively what all those updates are. I'm aware of the cloud search appliance and some of the other updates.
Let's follow up on that after. We have to kind of keep moving.
The update will be with NDA, so it's not known to public yet. That's why no one is talking about it. So it will come updates, but it's under NDA. That's why no one knows really, to be honest.
So the answer from the audience was that some of the details of that update are under NDA. So you can probably get them if you have an NDA with Microsoft, but we can't publish it over Channel 9 right now.
All right. So deployment and scaling. Let's talk about sizing. There's a couple main options for sizing, kind of in any enterprise software. You can scale up with more, bigger, better hardware, or you can scale out by moving components across multiple machines. One thing you want to be careful here is avoid sharing critical resources on the same machine. And we actually have a cheat sheet coming up about which components are resource intensive, CPU, network memory, disk. Got a good example here. Why you should benchmark your VMs. So let's say you've read the TechNet article, you've come to this session, you tell your infrastructure guys, here's what I need. And they say, okay, here's what you got. Well, you might be shared, in this has actually happened, you might be shared on 4 physical servers. There's 134 virtual servers running on 4, supporting tons of applications and 11 databases, and you're just not going to get the throughput that you expected or asked for. So before you go live, as you're setting up your system, you want to make sure you benchmark. Thank you for the SQL I/O question.
Yeah, and the more you can dedicate resources to those machines, and we have some guidelines around, dynamic memory allocation and also around shared disks. Make sure you're very cognizant of how that layout is. It's not just I need VMs with 8 gigabytes of memory, at 4 cores. You need to understand what's happening underneath the covers to ensure you don't get caught in some sort of ugly resource contention situation.
So I'm going to start by talking about a small topology. This information has been out there for a long time. It's readily available on TechNet. I'm going to go through it kind of quickly so we can get to Paul's demo, which is actually showing how to work with the topology. Small topology is basically our reference architecture of 10 million documents. And you can fit 10 million documents supported into a single index partition. So this is basically a distributed version of what we just talked about with the admin, content, analytics, and crawl component all running on one machine, and then a slightly beefier machine running the index and query component. Now, if you want redundancy, you just add an instance of each of those components as well as your index replica. A consolidated view of that, you got a beefier, bigger machine. We talked about scaling up. You can put all those components on one machine. The gentleman down here in the front has all those components plus SharePoint on one machine, the rest of SharePoint. And adding for fault tolerance, again, another instance of each of those. As we start to scale out, we go from 10 to 40 million items. And so now I talked about 10 million per partition. Now I've got 4 partitions to support my 40 million documents. And the same number of the other components, but they're doing a little bit more work, so I've distributed them across multiple machines, putting the admin and content processing component on one node and the crawl and CPC on the other. Again, I referenced the cheat sheet that might be coming up of why you might distribute them those ways. Quick?
Yeah, for 10 million items, that's not the boundary, right? This example is boundary 20 million items for the index?
Per partition, 10 million items. So here we're looking at 4 partitions, 40 million items.
So that's the boundary. You don't want to exceed 10 million out of it.
That's what we've tested for, right? So our engineering teams have tested for 10 million, and so it's not that you can't. It's that if you call support after putting 20 million documents on a single partition.
I'm only getting 2 queries per minute.
Yeah. So
what's up?
We're going to talk about high density mode, which allows you to put multiple partitions on a single server in just a couple minutes to do that.
All right, the demo, much anticipated.
Yeah, thanks. All right, so what I'm going to do is actually scale the topology right now, working together here. And so I'm going to start in central admin. Oh, zoom it. Sorry, let me just get zoom it running so I can zoom in on some of this stuff. Okay. So you can see here that I have a single partition and 1 replica. That's represented, just get with these servers here, all right? And then if I go into PowerShell, what I'm going to do for the sake of time is I'm actually going to run my partition, my script that's going to expand the topology right now, and then I'm going to walk through everything while it runs in the background. It takes about 10 minutes, so I'd like to be able to show you that output. Also, my topology doesn't expand for some reason, it's going to impact my second demo. So let's hope this works. All right, so this is how I define my initial topology with this script here. So if I zoom in a little bit on it, you can see that I've got my first 3 hosts up top here. I want to draw on here. So I've defined my first 3 hosts up here. Oops. Then I've gotten a handle on those search services down here. And now down here is where I'm going to start defining my roles for each component. So I've got an admin component, a crawl component, a content processing component, and an analytics processing component, all living on my admin node. Then if I zoom in on these other servers, so I define these index servers with a query and content processing component down below as well, all the way over here. And you'll see that I define the index partition right here. And so when I define my topology, if I define 2 nodes with the same partition ID, so I'm using 0 to start, then I will automatically create replicas. So I don't have to say create replica. I just have to say I need another index component with the same partition ID as another one. And that'll get it for me. So how do I grow that topology? It's pretty simple. For those of you who have had experience with our previous releases, specifically in the fast search world, you'll know that it was sort of quite a bit of work to go in and add columns and even add rows, as we used to say, so add partitions or replicas. And this is the code to actually expand your complete my topology and add 2 partitions. So let me zoom in on that a little bit. So I get a handle on the servers up here, the services up here. And then I'm going to clone my existing topology, because I don't want to define the whole thing. I just want to clone my existing one. So I get a handle to the existing topology. I clone it into a new topology definition. And then here, I'm actually adding 2 index components per server. So I'll zoom out on that. And that's what I do right here. And now I've made sure to create one partition, create an instance of partition 1 on one server, and an instance of partition 2 on one server. That way, if that whole VM dies, I still have those partitions up and running, right? So I wouldn't want to deploy 2 instances of the same partition on the same server. It kind of destroys my high availability strategy, right? All right. So let's see how our script is doing. It has not been 10 minutes, but sorry, we have to hop out to some slides anyhow. What you're going to observe is that when the repartitioning process is complete, I should have approximately 1/3 of the documents in each of my partitions. So it's redistributing, the indexer is redistributing that content for me. Now, my script takes 10 minutes, but I only have 25,000 documents in my index. So if you have a 10 million document index or a 15 million document index and you're trying to add a couple of partitions, it's going to take more time. So you'll want to benchmark this process. You'll want to schedule downtime. I've been told that you get query downtime with this. I haven't experienced it in this environment, but I think it's just because it's happening so quick. I've also been told by engineering that will not be a problem with SharePoint 2016. So in SharePoint 2016, if you add partitions, you will not experience any query downtime, which will enable you to do this very dynamically in your environment and be very flexible. All right, so I think that's all I had to show for now. So in just a couple minutes, once this script completes, part of my next demo, I'll be able to hop in, show you the new topology, and then we're going to actually shut down part of that topology to show you the resilience at the queried layer. So if I just switch into the slides, I just want to illustrate in the slides, I have a couple, exactly what we did here. So this was my initial topology. I had my admin component I didn't make highly available in this topology just for the sake of demos. I was actually hosting a bunch of other SharePoint services on the same server as my admin, content processing, crawl, and analytics processing component. I had a single partition with a query component, and then a replica with another query component as well. And so what I want to do, or what I just did, was grow it so that I have two more partitions, two partitions on two new servers, or two index components on each of these two servers representing two more partitions. I have my App Fabric cache and my web apps too. It's not really pertinent to the conversation right now. But so that's what my architecture is going to look like once that script completes. That is a high-density mode configuration. We're going to talk about it in more detail. That probably wouldn't work out too well in production because I didn't actually add any more resources to those two machines. It was more just to illustrate for the presentation. But yeah, I mean, if I was going to do that, I would want to double the resources that I need on that machine to accommodate that. So it allows us to leverage high-density mode. We're going to talk about it in a second, so I guess I'm stealing my own thunder. But it gives us the ability to use that scale-out model in the indexing tier. So I can add, if I have really beefy hardware, a lot of customers, part of their procurement process is just they have a standard server they get, and it's a lot more than I need for one standard server. I can take advantage of that by deploying more components in this manner.
So you're actually stealing my thunder.
Oh, sorry.
But that's okay. We got to talk about it at some point. So just continuing our example, we left off, jumped into Paul's awesome demo there at 40 million documents. We're now talking about scaling from 40 to 100 million documents. Nothing crazy here. My APC and CPC components are likely a little bit bigger to support the data volume. I've got another query processing component. I'm just up to, still using the 10 million benchmark number, up to 10 partitions to support the 100 million. I likely have to, not likely, I'm going to have to search over more data, thus the other query processing component, kind of share the load there. Now, this is, if you're, for example, crawling web content versus the reference architecture is really designed for typical SharePoint content. If you're crawling web content, you might need more analytics capacity, right? Because there's more URLs, more links to look at, things that go in the link database and analytics database.
The one goofy thing about that last diagram is it sort of looks like it's just 5 columns or 5 partitions and 4 replicas. It's just 2 replicas and 10 partitions.
Yeah, we ran out of room. It should just keep going on right past Paul's head. High density. So, newsflash, as of October 2013, cumulative update, we can support up to 4 partitions per node. So I won't dwell on this because Paul just talked about it, but talk about scaling up. If you have more hardware resources per node, you can get basically up to 40 million on a particular node. And you can support up to 240 million using this configuration. So this is a high-density configuration. It's how to squeeze as much as possible out of a particular instance without scaling out licenses indefinitely.
And you could see the hardware that we spec out in this diagram. We went from 4 cores and 16 gigs of RAM to 16 cores and 64 gigs of RAM.
2 terabytes from 500 gigabytes.
And I had a customer who one time came to me and said, well, we just added, we're getting slow performance, so we added an index component to this server, but it's actually gotten worse. And I said, well, did you give more resources to that server? He said, no. I said, well, there's your problem. So you need to keep that in mind. You need to continue to grow resources. So the question is, can you specify a different location for each one of those indexes? I'm actually going to ask Brian Pendergrass. Yes, that's the answer. So Brian in the
Great
audience.
question.
Yeah.
Get
Brian in the
there.
audience is one of our support engineers, so he's might refer to him a couple of times today.
That just happened. Free T-shirt.
All right, so here's the cheat sheet that Dan was talking about. You can see how we just sort of lay out the resource, the sort of the consumption model for each of the components in the architecture. I won't read through every one for you, but a couple of highlights. One, you'll see the crawler is going to primarily be network bound. So if you have low bandwidth in your environment or you're crawling a really large set of documents, lots of full crawls, that's where you're going to start getting constrained for that crawler. The disk, Dan talked about that temporary disk cache, so that's where it's disk heavy. Content processing component is primarily CPU bound, and because it's stateless, we can kind of instantiate content processing components where we have CPU capacity available to us. Finally, you'll see that indexing component. That's why we're giving it those dedicated servers in a lot of those architecture diagrams, because it is eating up a lot of stuff across the board. So it's going to be your heaviest component in general. High availability, the crawl component, again, it's more of a load. If you add a secondary crawl component, it's really more of a load sharing thing. It has its stateless DB. If the crawl component dies, it's easy to instantiate a new one, assuming that database is still up and running. We talk about high availability with the indexing component and the query processing component. The admin component, Dan touched on it earlier, it is now fault tolerant, but it works in a hot standby mode. So if one fails, the other takes over. It's not sharing any sort of load, not that it would need to. What's next?
So real quick, I saw some folks taking pictures. So
Thanks, Dan.
you must have heard already this week that this stuff will be available on Channel 9, not just in a video format, but the deck will be there. So just FYI. You might want to study it on the plane ride home, but.
All right, so cool. My script completed. So the first thing I'll go and do and show you is the fact that my topology is now grown in central admin, so in my search administration screen. So now I've got 3 partitions. And you'll see how they are distributed across different nodes. So my secondary, the 2 new servers I added in the topology are those final 2 rows. We've each got 2 partitions on them. So that script, very simple, very quick. It's actually, most of it's out on TechNet already. But if you're interested, so if you go to aka.ms/searchguys, that's the blog that I run. I'm not the only contributor to it, but I run. And I have a posting on that blog containing links to all the PowerShell scripts I use, as well as this code right here. So what I've done here is I wrote a simple JavaScript application that's pinging the search index and just bringing back some basic statistics. And so what I want to do is show you that I can shut down my host controller on one of my servers, rendering it essentially broken, and I will still be serving search results. I might see a few hiccups, don't get me wrong, but search is not going to go down completely. And so I'm actually going to bring down this 3 server here, and then you can see it's running a query processing and an index component there. So I'm going to bring that server down really quick here. I've got my services. Let me get my little widget here running in the background. Move that VM window over here. So I had all my stuff ready to go. You'll see errors under that green success. If I have any search failures, they'll show up in that green arrow. I mean, underneath that green success message. And there it is, all ready to shut down. When I was originally rehearsing this whole presentation, I was actually going into the Azure VM console and shutting down the VM itself, but that took a lot longer than just shutting down the host controller. This whole environment is running in Azure on IaaS, so it goes to show that you can run that.
Yeah, so that's the main service running search on that node. So simulating a server failure, it's gone. When that's gone, it's gone.
And I can show that it's gone by going into central admin, again, into the search service application management view. And you can see those red X's. We'll zoom it. Right there. And I have not seen a single blip on my, so this is a great day for the demo gods. Every time I've run this, I've had a couple of hiccups in the search, but this time it worked flawlessly, so. Yeah, right? I better turn this off before it backfires on me. Yeah. So the question was, do we have any recommendations on adding index components to the web front-end servers? And typically, we don't run the index components specifically on the web front ends. Sometimes we couple the query processing component with the web front end in order to minimize latency. So those requests are coming in, but it really comes down to that resource discussion. Do I have capacity on that web front end server for something like the query processing component? You know, how heavy is my search load? Where are those searches coming from? You know, what else am I running in the farm? So there's no technical constraint to doing it. It's really more of a resource capacity.
Yeah, I mean, there's no reason you need 500 gigabytes on a web front end, right? The indexing component is the pig of what we've shown so far, and that's why we generally separate it, and maybe you can put a query processing component on there. So just the specs just don't.
Yeah, so the question is, do we recommend putting the index component on an application server and maybe putting the query processing component on with the web front? Yeah, that would probably be a more typical architecture is what I'll say. You know, these are guidelines up here to kind of helping you figure out where stuff goes. But the specifics do really come down to what your workload is and, you know, what kind of servers you'll have access to. I just don't want to give you anything definitive, you know, without knowing a little bit more. That's all. The classic consultant move. I'm sorry, I can't hear you from that far back.
If we were to put a dedicated WFE for search, or WFEs for search, would it be better to have like WFE and a crawl components in those dedicated servers?
So would it be better if you're going to have a dedicated WFE for search, for the search farm?
And then that, if you run the crawl,
Would it be okay to put the crawl component on there?
Yeah, I mean, when I think about it from a resource constraint process, I don't see why not. I don't. Again, that's not a typical architecture. We typically separate. Let me put it this way: the components in search with typical architectures is the only ones that might sit up with the WFE is the content processing component. That's more of a typical architecture. That's not to say you couldn't, but really it would come down to sort of the layout of your environment, where you have capacity.
Yeah, so you're looking at networking there. I mean, I would think that if you put the crawl component on a dedicated search WFE, well, it's not going to local hosts because there's no content coming through the search WFE, right? That's the crawler's going out to something else, but it's taking up network bandwidth for what you would have for your users as query traffic. I wouldn't do that. That's my favorite answer.
I'm sorry, what was that?
You can have a web front end as that particular role of a server, but only, like say you got 3 of them, only load balance 2 and have the third one for search latency.
Yeah, so what you're talking about is if I have a dedicated WFE that I point the crawler to,
Yeah.
right? Was that your question?
Yeah, that
Oh,
was my
I'm sorry.
Oh, okay.
Yes, that is a standard pattern.
I was thinking about the WFE holding the search,
Yeah, just
hosting the
marrying
search
those
center.
components. Yes, it is a common pattern to have a dedicated WFE that you point the crawler at so that the crawler's load on that front-end experience does not impact your end-user experience. Thank you for helping us with that one. Brian, you have something to say?
One of the key aspects to add to that, though, is a lot of times your bottleneck web front end is not the web front end, but the underlying SQL database, which is going to be shared among all your web front ends, regardless if they're load balanced or not.
Yep.
So Brian's comment for the recording was that often your bottleneck on the web front end is not the web front end itself, but the underlying SQL. And by dedicating a web front end for crawling, you're not necessarily circumventing that constraint. Sure. So the question is, if you're doing an index reset, you lose search, and is there any thought around allowing you to do an index reset and rebuild a secondary index while still serving traffic on an initial index. I guess my question is, why are you doing a reset index? That does delete all the data. So in the past, what we would see is people would think that they had to do that to crawl other content. I've heard customers say that. But you can still do a full crawl on top of your existing index, and it uses the incremental indexing capabilities to refresh your entire index. So I don't know if the engineering teams are working on a feature like you're talking about, though. Not aware of anything.
So there's no quick questions, just quick people that ask questions. Go.
All right, so I'm glad my demo, oops, not in the demo, or the PowerPoint. Glad my demo worked pretty well. So this is just what I did, just a little more illustration. So I pulled off that one component. You saw that we didn't lose search. So it would have been a longer demo if it hadn't worked. All right, so let's go into hybrid a little bit. So with this week, and over the past month or so, we've made some really cool announcements about the hybrid capabilities, but we had existing hybrid capabilities in SharePoint 2013 anyway. So this sort of lays out what our hybrid options are. And the hybrid options you choose are really going to be specific to the type of user experience you want enabled for your users and maybe some of the environmental constraints you have. But in that top left-hand portion is the query-based federation option. And essentially, this means that I can search from a search center on-prem and get cloud results as well as on-prem results, or search from a search center in the cloud, get on-prem results as well as cloud results in a single screen. The other thing that we introduced this week, really, for the most part, is this cloud search appliance. This is going to allow us to crawl on-prem content and push it into Office 365 and SharePoint Online for search. This gives us that unified index inside Office 365. So I'll go to that in just a little bit more detail. But first, let's talk about our federated hybrid options. So we can actually do 3 different modes when it comes to federated search, this federated query model. The first is one-way inbound. This means that if I'm in the on-prem search center, I can get on-prem results as well as cloud results. Office 365, SharePoint Online search results. Second is one-way outbound, which means if I'm in a search center in Office 365, I can get on-prem results as well as the Office 365 results within that search center. What we see with most of our customers is the two-way hybrid search. And this means that if I'm in the on-prem search center, I can get my search results from Office 365. If I'm in my Office 365 search center, I can get my on-prem results as well as the Office 365 results all on a single screen. For those last two, you'll see there's that little friendly device right in the middle of that talkback to the on-prem environment. That is a reverse proxy device. That is essentially a piece of hardware that you have to stand up in your environment that will broker a trust between your on-prem environment and Office 365. That's probably the most complicated piece of configuring that hybrid environment. So I just want to give you a quick look at the experience within Office 365, within a hybrid environment. A colleague of mine lended me his environment to show that to you. Just to be clear, so this is the hybrid search. I haven't been privy to the bits for the hybrid, the cloud search appliance, so I don't have that. But what you see here is I have 2 environments. My on-prem, so right now I'm in a SharePoint Online instance, which you can see up here. So I'm in the SharePoint Online Search Center right now. And what you can see are 2 result blocks. The top result block is actually coming from the on-prem environment. And those are search results from the on-prem environment. So if I zoom in, I can see that this is SharePoint.nellimo.com versus nellimo.sharepoint.com. Subtle, but important, because that's that SharePoint on-prem environment. If I scroll down a little bit, I get the primary result block. And those search results are coming from nellimo.sharepoint.com, so that Office 365 environment. Conversely, if I go into the on-prem environment, so you can see up here I'm in SharePoint.nellimo.com. If I come down here, the first set of results is from the cloud environment. So my first result block is the cloud environment. And then my secondary result block down here is my on-prem environment. And I bring this up, and I wanted to show this to you because this is that federated hybrid search experience, and we don't do result mixing out of the box. So we don't do that interleaving of result sets so people have no idea where their search results are coming from. That is what we're trying to affect with this cloud search appliance. We want to allow you to take your on-prem content, push it into Office 365. You have that unified index. You have that unified set of search results. You'll have unified refiners. You'll be able to leverage things like query rules and result sources, result sources that filter out on-prem results or vice versa. So you'll be able to really harness the full power of the Office 365 search engine, and that would also include Delve and the Office Graph. So if you take advantage of this cloud search appliance. The cloud search appliance is essentially a crawler that crawls all this that can crawl any content that your on-prem crawler could crawl before. It just sends it to a different place. One more point about that. Oh, the one thing is it'll be released with the update to SharePoint 2013 in sometime this calendar year is what we've been told. So the product team is nice and vague about it. And then it'll also come in SharePoint 2016 whenever that releases. So there's a couple of trade-offs when we start looking at our hybrid approach, or a couple of things to consider. I think there are a couple of important things I want to point out. One, the search experience for your users is only going to be as fast as the slowest link, right? So if my on-prem search environment, if I'm searching from Office 365 and my on-prem search environment is slow, it's not going to be improved because I have hybrid, right? Now, we have timeouts and that sort of thing, but I could impact that quality of experience. The plus side of something like the Cloud Search Appliance, however, is I have the opportunity to relax my on-prem architecture. If I start moving content into the cloud, I can stop managing all those partitions and replicas potentially, because I've moved that content in the cloud, and now Office 365 is doing all that work for me. So some things just to think about. As I said, there was a presentation Wednesday, late afternoon, was the last presentation of the day on Wednesday by Catherine Hammerwald and Manis Biswas that talk a lot more about this hybrid search appliance. So I encourage you to check that out if you need more details.
So we've largely been focused on search up to this point. What does the search architecture look like, the search farm in particular? We talk about databases very slightly. Let's zoom out and have a look at your entire SharePoint farm, particularly multi-farm deployments, and what are the options for setting that up? Because as you start to go into large organizations, you see there's lots of considerations to be had. So the first thing, and this is we're looking at this from a search perspective, but we're zooming out a little bit. First thing that we see most often is that users will have a central search farm. This serves multiple content farms. It's easier administration because you only have one search farm to deal with, and better relevancy, which results in the better user experience. The better relevancy component of that, with having one search farm search multiple SharePoint farms, is you get the results, and we've talked about this so far, in one result set. So they are relevant compared to each other. They are mixed together. The queries rank those against each other. So that gives you that one unified experience without having different result blocks on the page. The next possibility is a distributed deployment. So that's where we have a search index on each farm. People are able to go directly to that farm and search directly. You can also bring in the results from the other regional farms into your search farm, right? It's very easy to set up a result block that points to another search service application in a separate farm and bring those in on a page. Again, those results that are now on the page are not mixed at all. They're just in different blocks, but it is an option. And then Paul talked about hybrid, so I'm not going to talk about this a lot. But that's when you have Office 365 federating back to your on-prem search farms. And he mentioned how this is a migration path to the cloud instead of saying you have to have one or the other. So when to choose federation? When you have a slow WAN between remote farms, so that precludes the crawler from performing at any particular fast pace. Regulatory restrictions. This is one I'm actually going to show. The next slide or two is an actual live demo of pretty much needing all these things at the same time, where data has to stay in a particular country. Users actually want results from local sources. I keep saying, like, if you merge them all into a central index, you get better relevancy, a better end user experience. But maybe not. You know, if I'm in a different country, I just want to search my stuff. I don't necessarily care about what the rest of the world is doing. And then obviously, when you're federating between hybrid O365 or between O365 and on-prem. So here's an actual example of a customer I'm working with that kind of needs all of these. They've got the O365 environment that has hosting the My Sites and Team Sites and a host of other data. Then they have an on-prem shared farm, as well as some custom farms. So ideally, if you're just a person and you want your data, you put it in the cloud, it's all taken care of, it's crawled by the search center. If you have more specific requirements, you can go to the shared farm, which also gets picked up. And then if you have like super custom requirements, you can put your data in a custom farm or your application, and then you need to add that URL to the search center. But in all cases, the main enterprise search farm, which is on-prem, is crawling all of those as data sources. And what you get, I'll mention that in a second, is a unified search experience across all of that data. Now, what I should mention here, because we just had the hybrid conversation, that environment on the left is O365D.
Dedicated.
Okay, so it's dedicated. Not many people have that. This is a good example. It is available, but it's not likely. Okay, you can't actually crawl O365. It's not allowed.
Yeah, so the multi-tenant environment, which is where most customers sit, you cannot crawl that from on-premise.
So zooming out now from that, there's multiple farms looking around the world. So we were in that upper left quadrant in that last slide, and now we need to talk about the regulations, right? So we actually have SharePoint farms in other countries where there are restrictions that the data cannot be taken out of that country. And that includes the search index. So we can't crawl it and index it because too much of that data will be stored in another country. So in that case, we have to federate. So again, we've got the search coming into the search center and going out to both the regional search farms as well as the extranet. We're talking about remote result sources. So we have to configure those and get them on a page or a vertical, some other way to present them than having them actually in the search index with that unified experience we talk about.
Dan, how many documents do you host in that enterprise search farm? Do you know?
I think we're at around 15 million.
And how many? So is that just 2 partitions?
Yes. It's actually 3 partitions. It's built to hold more, right? Future growth, but we're at 15 million, so cool.
All right, so if we're talking about, we'll do a few quick slides on backup and recovery. We invested quite a bit in backup and recovery in SharePoint 2013 for search. It's important to keep in mind for everybody that's been with SharePoint for a really long time that the SharePoint search index does not live in the database, much like the crawler content. When a crawler crawls content, it's not putting it into the crawl database. So we have to do more than just apply high availability patterns to our SQL databases. We also need to do special backup and recovery operations to the index. So we have some commandlets. So we have a PowerShell commandlet and a way to do it through the UI so that we can back up everything that's in the index. We do a point-in-time recovery. that sort of takes a snapshot of it and allows you to restore that topology back up again. You still want to apply SQL high availability patterns to your search-related databases, though. So you can see the ballpark figures down below about how long it takes. There is some crawler downtime and some indexing downtime during this procedure. So if you have stringent indexing latency requirements and freshness requirements, you need to think through this procedure very carefully. So I won't read through those, but you can see that it took about 8 hours to run that backup, that secondary backup, and 6 hours to restore. And in that time, you have to assume during that backup time, about 10% of that time, you're not going to have the crawler or the index getting updates. So you can do it through the SharePoint Central Administration UI, and then there's also the commandlet. Oops, I'm pointing at the wrong thing. And so how does that process work? So first, we're going to back up the index itself. So the indexing process is going to be paused. Feeding is going to continue, and it's actually going to get written to that journal that Dan was talking about earlier. Then in the second phase, we want to back up that journal. And so the content updates that come through to the journal are actually going to get updated to the index, but feeding itself is going to be paused. So the journal is going to get, the entries in the journal are going to get applied to the index, but there are going to be no more entries coming into the journal because feeding will be paused. So during that time, you're going to see some freshness delay. You will be able to serve search during that entire backup process, though, and that tends to be the more critical requirement. Users don't tend to notice for most enterprise search workloads that documents haven't been updated in an hour or something like that. What they notice is that they can't get search results, and we won't have that problem here. Your question?
Are the query rules in those things all backed up as part of this, or is that stored in content database?
That is, those are stored
admin database,
in the search admin database. Yeah. So yeah, they get backed up however you apply your high availability for SQL.
All right. Real quick, I'm going to touch on monitoring at a super high level. It's sort of a little part. We're almost running out of time of this presentation. It's a very deep topic. There's a million things that can go wrong between and inside of all of those components we just showed you. I'm just going to give you a high level of the things to kind of look for to be like, uh-oh, Brian,
who's left,
who's gone, and another colleague of ours, Chris Loringer, actually did an amazing session just going and grabbing their deck from Checkout Channel 9 will be of value to you, but I encourage you to watch it. They go through the SCOM monitoring and exactly what to look for and the triggers and walk through the life of a query and the ULS logs. It's really great stuff. So, real quick, search diagnostic sources. So you have, obviously, Paul's already been through this and showed you the SSA where you can go in the search administration UI. And then you have another option, PowerShell. Get Enterprise Search Status is the main character there. The search health reports in the UI. So part of the analytics also generated from other things. You've got your feeding performance, query rate, latency, and like zero-hit query reports. Monitoring and telemetry. I just mentioned the SCOM management pack for monitoring search. Deep dive into that at their session. Also the ULS logs and Windows performance counters. So we were showing you this screen actually in Central Admin a few minutes ago. You saw the two red X's. This is basically what you would see in a mildly healthy system, but got a few problems. One, the search admin component, secondary, is down. Okay, that's the red X. You're going to need to do something about that. It might be a server down, might be the network is down in between components. It's unreachable for some reason. The yellow guy is usually a degraded component. Most of the times I've seen it, it's on an index partition where the index is catching up, the replicas aren't in sync, so you're serving like current search results from one and not from the other for one reason or another. So the Get Enterprise Search Status I was just talking about. This gives you the component state for basically the search components. It gives you a little bit more information than that pretty little picture in the UI, including active, degraded, and failed items. You get a little bit more about the indexer nodes as well as the primary and secondary roles for the stateful high availability components that we talked about, admin, indexer.
If you can actually get to very low levels of detail about like how many documents per index partition, what is the primary replica, what is secondary. But you have to do a little bit of work to drill through that.
And just sort of detailed diagnostics for the indexer. Yeah. The status for the analytics processing component, too.
Documents, is that a switch that you use with this particular command?
To get the number of documents? Actually, it's not. You have to, there's a switch to get more detailed information about the indexer. They're almost like, they're almost like perf counters in there. And so then you have to parse those strings. So you have to know a little bit about what you're looking for.
And be a PowerShell.
Yeah, and be a PowerShell ninja.
Help me out.
We burned a lot of time clicking that clicker.
Hit me ahead. Who wants a free clicker? This last one is available on the TechNet Wiki. It's something written by a colleague of ours, Knut Brandrud. It basically uses a bunch of, you can search for this and find it. It uses a bunch of the different commandlets out of the box to give you like this really nice, detailed, holistic picture of your search architecture.
All right, so just to recap what we talked about really quickly, we described all the search components, what they do. We talked about how they can scale and how you can grow them. And we talked to you about the different resource constraints or the resource greediness of each one of those components. I introduced some of the hybrid, and I hope I made clear to you guys how incorporating those hybrid elements can impact both your user experience and your architecture. Did some backup and restore conversations, and finished off with some monitoring. So just before anybody asks more questions or leaves, we would really love your feedback. 5s are good. 1s are bad. I've heard other people say 5s, so hopefully we're going to get lots of 5s.
Valuable to somewhat valuable to not at all. Who's an extra large? I'm sorry, sir, in the back. My throwing arm.
I saw somebody ball one of these up earlier.
It all came unraveled.
Yeah, large. I'm going as far back as I can.
Whoa. He asked a lot of questions,
Yeah,
so
you
he
did.
earned it.
All right, so we have some questions. Go ahead. Yeah, we're not trying to ignore the question.
So as far as service accounts, what are the best practice as far as managed and password don't expire that you recommend for search?
So the question is what are the recommendations for using different service accounts for different components in search?
Yeah. Well,
Dan, do you want to take that one?
I don't.
No.
So just an example. On our 2010, we're in the middle of migrating, but on our 2010 form, every time that the search service account changes, because we have it set as managed, it brings down the search service. Like, it happens frequently.
So when you said when the password changes?
Yeah.
So can you set the password to not expire on those accounts?
We have a policy that, make it
That's what
difficult,
I've seen
but
most
that
people
would
do,
just do it
because
for
you don't
both.
want to be chasing that around,
Okay.
losing components and stuff because
Okay.
service accounts are logging off for the night. Check out.
Is that it?
Yeah, that's it. Thank you.
No.
Yeah. Okay.
One question regarding the analytics processing component. It has, apart from search, also this usage analytics. The question is, if I have a dedicated search farm and some content farms, do we have to consume the service proxies from the content farms to get the views of the documents into the ranking?
It's a great question. I don't know. We could follow up on that one. When you're consuming search outside of SharePoint, or outside of SharePoint 2013, I guess I should say, you have to do special wiring to get the usage analytics into search. And there are REST APIs for that. However, if you're using just distributed SharePoint 2013 farms, I'm not sure. I would think it would just work. Just work, right? Well, let's follow up on that. Talk to Christian.
Yeah.
He has my contact information.
Again, with the O365 example, there are certain things that just don't work that do with the total on-prem farm. And I think a couple of those analytics ones are.
So we're on-prem. We have, with Fast 10, you had the order of shutdown, you had the query index, admin, then bring them back, admin index query to make sure everything worked properly.
Yeah.
Is there a similar process that for 2013?
The question is there a recommended approach to start up and shut down your components?
Yeah.
I would be inclined to say it's similar.
Okay.
So that admin component sort of knows the topology, right?
Okay.
And so you want to start up that one first and then start adding the other components.
The others are going to likely come up and ask,
what about,
what's my role?
Yeah.
What about shutting it down? Is there a proper shutdown first? 'Cause we actually have to reboot our servers, security and all that kind of stuff when we do the patches.
I don't believe so. So the example that I was showing up there when I went through the partitions slide, when they're applying patches in MSIT, they're just shutting them down.
Okay.
And whoever comes up is the first. It's not the only place that would matter, because most of them are stateless, is so the admin component and then the index partitions.
Okay.
And unless you care which node, for management purposes, whatever, in a spreadsheet, which node is the primary indexer, it doesn't matter.
No.
But do keep in mind, though, that you've got this data flowing through the process. And so your crawler, if you shut down your indexer while your crawler's throwing content, it doesn't realize what's going on. I think they're probably safer approaches.
Yeah, when I was talking about that, I was kind of assuming that you had stopped activity.
Yeah,
we
stopped
okay.
the crawls and
querying
everything.
and crawling.
But we've also run into problems where I actually had to script out the whole process to PowerShell, and it works because the previous engineers who were doing it, I'd have to come in the next morning because we were not getting any results, and I'd have to redo the NCTRL stop for the query, and then I got it working, but for whatever reason, they couldn't do it the night before. So I was just wondering if but we always pause everything or stop the call.
Yeah, stop feeding, put up that splash page, search might be down, whatever.
Yeah.
But you should be able to cycle those, as Dan was saying, you should be able to cycle those servers without even bringing search down at all. Like if you're doing, regular maintenance, how complex you want to write your scripts and stuff.
Well, our SharePoint's down, so and SQL's down all
okay.
at once. So we have a time where they just shut
okay.
everything down. So, but bringing it back up was the problem.
Yeah, but to expand on your question a little bit is to say that you shouldn't necessarily you should be able to do patching of both your both Windows and SharePoint without experiencing any search downtime if you're strategic about which nodes you hit at what times.
Great, thanks.
We're crawling database through BCS. When on the incremental crawl, it is crawling full record. How to set up incremental crawl in BCS?
The question is, how do you set up incremental crawl in BCS? So I've only done a little bit with BCS, but I am pretty sure there are ways to configure your queries into the database to use the state tracking mechanisms within the database itself. So you need to be aware, it needs to be aware of some sort of metadata on the target content that indicates that it has been updated recently.
The changed ID enumerator.
Which one?
You should perhaps implement the changed ID enumerator. It gets called for changed items.
We put the date. We are following one wiki site. Not able to figure it out. Something they mentioned here. Is there anybody can know about BCS with the feedback and contact?
We could point you at some resources. So if you email me, paul.summers@microsoft.com, I can point you at some resources. And actually, this guy from Raytheon, they do a lot of connector work, so you know what I'm talking about.
There you go.
Uh-oh.
I was wondering, how do you measure the IOPS? What is the best? Is there any tool available?
SQL.io is generally the...
So the question was, what tools do you use for measuring IOPS? And SQL.io, yes, is the one that's what our engineering team actually uses, is SQL.io.
Mm-hmm.
Stuff like that. So even the smallest farm that you would ever build, you always 100% of, I know not always, but as much as possible, as long as you can afford the hardware, always
No. We showed a slide that showed it put on there, right? The consolidated view.
Yeah.
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 But
think
you also, and keep in mind that you might need to project a little bit. You know, a lot of times what we find in search, this has been my experience with deploying search since I started working in enterprise search 10 years ago, is that people stand up a good search solution and it's not getting much traffic. And next thing you know, everybody's like, wow, this is pretty good. Because the old one sucked, pardon my French, but the old one sucked, right? That's why you got a new one. And they're like, all right, well, we stood up this new one, people like it. And 6 months later, oh, it's slow, the results aren't relevant, blah, blah, blah. It's because
you're gone.
Yeah, you're gone. More people are using it. There's more content in there. There's more activity. And people have higher expectations. So you have to kind of project and be prepared to grow your architecture.
Is it more likely that bad performance like that for like querying and everything is more due to lack of resources on the search server or the SQL, the IOPS between SQL?
There is no critical IOPS in the search experience with SQL.
Being able to go out there, come back, just being able to query the results from the DB, come back.
That's my point, is when you, search does not, the search process, that search processing flow that Dan outlined, does not touch SQL. It goes to files on disk. The SQL, so SQL's involved. The crawler does its thing, goes out and gets content. So if it's pulling it from SharePoint, obviously it's hitting SQL, but that's sort of not search's fault, I'll say, right? And then it does state tracking in the crawler database, and then there's some of that event logging. But that primary indexing chain, there's no database in there. There's no SQL database in there. Yeah, it's all files on disk. Yeah.
All right, so SharePoint 2013.
Thanks, Yap.
SharePoint 2013, we have a dedicated WFE for search using alternate access mapping to hit it and bypass our load balancer. Crawler works great. I use the server name mapping to get the URL correct so that it switches out the alternate access mapping to the real URL. Displays fine in the search results, but the link still points to the WFE. What am I doing wrong?
I've heard this problem before. I don't know the solution off the top of my head. Go out to Steve Peshka's blog as a starting point.
Okay.
I know that he's addressed this before. His blog has moved because he's no longer with Microsoft, but if you search for Steve Peshka's blog, he's one of the foremost authorities on SharePoint.
He's the 365 monitoring guy?
I'm sorry?
He's that monitoring guy?
He's basically the foremost authority on SharePoint, as far as I'm concerned. So,
all right.
Yeah, check out his blog. If you can't find your answers, paul.summers@microsoft.com. I'll help you sift through it, figure it out.
All right, thanks.
So we got Steve Peshka, Brian Pendergrass, Chris
Lander. Hey, you can't know everything about everything. Sorry.
Go off of his, is the site data functionality no longer supported with 2013? So within 2007 and 2010, on the web application, you specify site data servers. And whenever SharePoint would crawl, in the first interaction, would get back in the XML what servers to hit for the content. And then it would limit itself to those servers somehow.
You're talking about the crawler? Yeah, so you specify the endpoints that you want the crawler to hit.
And 2013 doesn't respect that. At least not in my phone.
So if you set your crawl, when you create your content source and you say, go to these sites, it doesn't respect that?
On the SharePoint web application, you specify the site data servers that are supposed to be the servers that SharePoint crawl on is.
Oh, I see what you're saying.
So are you talking a 2013 crawling a 2013 farm, or the 2013 crawler crawling something else? Because there's tons of ways to set up in your SharePoint 2013 sites, whether you want to re-index this site or don't index it, or all kinds of other things.
You're talking about getting a dedicated WFE